Good afternoon. This is our final session this afternoon. Thanks for bearing with us. It's going to be a good session with a lot of diverse information. From Tuscaloosa, I'm from University of Alabama, Tuscaloosa, we have Dr. Chuma Ngawi, who is an assistant professor of civil construction and assistant professor of civil construction and environmental engineering. Did I get that right, Chuma?
Yes, you did.
Your program name. And he's going to be presenting exoskeleton and temperature interactions relative to how exoskeletons function, worker fatigue, and I believe that you're going to be joined by at least one of your doctoral students. Is that right?
Yes, but he's not going to be here today. He had another engagement, so it's going to be just me.
Fantastic. Well, it's your program. Take it away, please.
All right. Thank you very much for the introduction. Yeah, Chuma Ngawi at the University of Alabama in Tuscaloosa. And I will spend the next about 18, 19 minutes talking about a pilot study that we are currently working on that's funded by the Deep South Center for Occupational Safety and Health Research. This study, or the flow of the presentation, I will provide you some information about the reason why we are conducting the study. I'll talk a little bit about the experimental process, how we get our data, then spend some time on the results, then the key findings, then the potential way forward, and I wrap up with some references that might be relevant to the audience. So first of all, I think this is a safety conference, so everybody here knows that safety is a pain point in most industries. But specifically in construction, it's a bigger issue because we record the highest fatality rates across all industries. 1 out of 5 fatalities happens in construction industry. Now, if we look beyond fatalities and we look at other data streams, especially around injuries, more specifically around work-related musculoskeletal injuries. Again, the numbers are not very favorable to folks in the construction industry. We consistently report higher numbers compared to other folks, and that's a concern from multiple perspectives. One perspective is also going to be around cost. When we have all these injuries and fatalities, the costs impact increases significantly. Now, beyond safety, we also have other concerns in construction, and one of the major ones is around productivity. We struggle a lot with productivity, especially when we compare our numbers with folks in other industries. One of the interesting data that I have seen is the productivity over the last 20 years, pegged at 2017, show that we've only improved by 1%, which is abysmal, to be honest. If you compare that number with other industries, I think it's about 4 or 5%. That's what we see on average across all other industries. And because of this drop in productivity, we lose money as well, right? There's about 1.6 trillion left on the table that it's tied to productivity loss. So the question here is, how can we improve safety and productivity within the construction space? Now, multiple studies have tried to find ways around this problem. And one key thing that we've noticed, at least based on research, is that technology provides us a great opportunity to bridge that safety and productivity gap. Now, when we look at technology that could be used for safety, my grad student went through a systematic review. I was able to look and identify multiple technologies that we can use. And one thing that stood out that could help impact both safety and productivity at a decent level was the use of robotics and automation. Now, usually when you hear robotics, most folks think about the single task robots or the on-site robot, but we actually have different types. We have the wearable robots, which is the ones we put on. We have the remote operated robots, which is going to be your drones and your unmanned ground vehicles, or UGVs. Then obviously we have the ones that most people think about, which is your single task or on-site automated robotics. But I'm going to be focusing mainly on the wearable robot, or the exoskeleton, also referred to as exosuits. It's a piece of technology that is becoming more interesting to use in multiple applications. We see folks use it more in the manufacturing automobile space, but some folks have started trying it out in construction domain as well. Now, we have several types of exoskeletons. They are primarily categorized into two boxes. One is the passive exoskeletons, and the other is the active, which is more responsive. It's a smarter system compared to the passive, which just provides you with a standard level of support or constant level of support. Now, these exoskeletons can support multiple tasks in construction, and especially those where we tend to see higher rates or higher concerns tied to work-related musculoskeletal disorders. And here, just a view of a few of the technologies that we have out there. Now, when we talk about technology and what it can do for us in construction, it's also important to contextualize that the application as well. Because a lot of times when we try to assess the use of technologies within a domain, we ignore some of the critical elements of that particular domain. In construction, one of those critical elements would be temperature, because most of our work is done outdoors. And unfortunately, we report one of the highest rates of illnesses that are tied to heat or the temperature. So it's important that we also assess the performance of technologies within the context that we would use them in this case, within looking at temperature. So what we try to do in this study is to find out, first of all, how to test the technology within a context that considers temperature. So the goal was to develop a process for achieving that goal. The next was to actually test the technologies within that particular context and see if the exoskeleton does actually improve workers' performance, looking at muscle activation, muscle fatigue, as our metric here, and also assess end users' perception of the performance of exoskeletons. So those were our three starting objectives, and I'll spend some time talking about each of them. So the first was to come up with a method, like how do we plan to collect this data in a way that it would be empirically sound? So we designed an experiment focused primarily on drilling, where we developed the rung, and we also put together a process for collecting data on exertion, which is force-related, and also errors. So we, as you can see in this particular slide, we came up with the rung. The rung has different holes, and the holes, the diameters range from 0.5 to 1 inch. We also put together it's an actual drilling device, but we had to augment it for the research. So we put together a load cell, and we came up with our drill bit using 3D printing, and it's all connected to a process for streaming our data into the data streaming that we use for this project. We also came up with a process for controlling the pace of the research of the process, and we also came up with a similar process for controlling the accuracy as well. So we put all that together to come up with a sound methodology where we could control for the amount of force, which we pegged at 70 Newton, which is seen as the typical amount of force needed to complete a drill. Then we also controlled for the timing between drills, creating a 3 seconds gap between the completion of the drill and the start of the next drill cycle. And we did all that using both audible and visual alerts to the participants. So with regards to the experiment itself, we had 4 conditions that we tried to that we utilized. That's a 2x2 experimental design. The first 2 is looking at the temperature, which we pegged at 72 degrees Fahrenheit and also 92 degrees Fahrenheit. And we tried to control the humidity to be roughly around 50% RH. Then we also have 2 other conditions, which is going to be the with exoskeleton condition and without the exoskeleton condition, making it 4 conditions. The drilling experiment lasted for 15 minutes, and the way it worked is somebody comes in, we collect the data that we want to collect as the baseline, they rest for a little bit, then they spend 15 minutes doing the drill, then they close out the rest a little bit, and we collect some data from them. And they had to visit the lab 4 times. Actually 5 times. The first time was to collect the baseline data for the maximum voluntary contractile force, which we use to normalize the EMG data. Then the other 4 times they visited was tied to each condition. So 1 visit per condition. And the very first was to collect baseline data. So So with regards to data, we were targeting muscle activation as a metric for capturing fatigue. And we looked at two primary muscle groups, so the anterior deltoid and the posterior deltoid. And the reason why we focus on these two muscle groups was because of the activity that we're going to perform is drilling, and it's drilling at the eye level. So those muscles will likely be activated during the process. The other thing that we also try to do, if I go forward, just a picture of the anterior and the posterior deltoid and what that looks like with someone putting on the exoskeleton. We used an exo vest for this experiment, and you can see the sensors already connected to the participant. One thing that changed from this picture that you see here, and what I'm going to be reporting, is that we initially planned to collect data on the bicep brachii, but we noticed that during the experiment, the electrodes were moving so much, which is here, due to the way this device is connected. So we basically eliminated this data. We just focused on the posterior and anterior, on the left side and on the right side, which is what I'm going to be reporting. We also measured the perceived exertion using the Borg scale, which is more of a standard. And we also captured error rates. And we did that by looking at the number of strikes per cycle. And the drill bit size was about 0.3 inches, while the holes that we were using for this experiment was roughly an inch. So again, when the drill bit strikes at the edge, we consider that an error, because we told the participants to always try to target for, they should avoid striking the edge of the rung. So with regards to the experiment itself, we had 10 participants. Again, this is a pilot study, so we tried to control it by, focusing on only male students from the construction program. We hope to expand this into a bigger demographic from construction industry and having more diversity. But in this case, we just had 10 students, and this just shows the summary of their data. Age-wise, they ranged between 18 to 31 years. And in terms of height, you can see the height there from about 65 to 74 inches. So again, we had some diversity, but we've not analyzed the data considering some of these metrics that we have here, some of these demographic factors. We'll do that subsequently when we have larger sample sizes. So jumping into some of the outcomes, when we looked at the error rate, one thing that we noticed was that if we looking at the error rates within the hot conditions, there was a spike. So we can see over here for hot condition, which is HT, which is in red, without exoskeleton was the highest. When you look at hot condition with exoskeleton, was relatively high, but was lower than the condition without the exoskeleton. The same thing was observed. The condition with the exoskeleton in room temperature was again we saw relatively lower errors overall compared to the condition that we did not use the exoskeleton. So what we can infer from this is, using exoskeleton both in hot conditions and in cold conditions, we could possibly see reduction in errors, which again could help us increase productivity. Again, not generalizable, it's just 10 folk students that participated, but it's something that's worthy of further research. Looking at the activation, muscle activation, we had to go through a process, the standard process of cleaning up the data, knocking off the noise using our filtration. I could go into more details if required, but we focused on the peak activation. So that's 90 percentile of the participants' maximum voluntary contractual levels. And doing that, we did that for the with and without exoskeleton conditions and for the hot and cold condition as well. So this slide shows the room temperature with and without exoskeletons for the peak activation level. And what we can see in this particular figure is that there wasn't like a big difference with regards to the activation for each of the muscles. For your posterior deltoid on the left side, anterior deltoid on the left side, posterior on the right, and anterior on the right. There wasn't a big difference. You can see a little bit of a reduction when you use an exoskeleton for the posterior. You can see some reduction elsewhere as well, but again, it wasn't that significant. Now, when we look at the hot temperature, we see something slightly different. So without the exoskeleton, which is the dark blue, And with this EXO, which is the lighter blue here, we see that without exoskeleton actually required more activation, and with exoskeleton required less activation, and that was consistent across all 4 muscles that we assessed in this particular study. So what we can infer from this data is that while the impact wasn't so much for the 15 minutes experiment that we conducted for room temperature, in a hotter condition, we tend to see more of a drop in activation level, which is positive, which is good, because it tells us that in hot conditions, exos might actually provide more gain overall. Again, it's still constrained. We need to do a little bit more in a broader sample with construction workers to generalize that statement. The next thing here was looking at more of perceived exertion, so perceived discomfort. We tried to ask participants what they feel as they went through the experiment. And what this figure here shows us is that on average, looking at the 10 participants, the hot conditions, they had higher perceived exertion rate. Now, when we look at it across the exo and no exo conditions, unfortunately, we noticed that the exo conditions had slightly higher perceived exertions, which is not something that we expected. We were expecting that the exertion was going to be lower when you use the exoskeleton from a perceived perspective. However, some folks have said in the past that because of the weight of the exoskeleton and people maybe not feeling very comfortable, that the perceived exertion might be more when you put on the exoskeleton. So again, there is some, literature out there that supports this finding, but we're expecting the inverse outcome. With regards to the very last thing we looked into for this phase of the study, we asked participants about their perception of the utility of exoskeletons. We assessed the utility using multiple constructs that we identified through a review of literature. These constructs are tied to a process called technology acceptance model. And we asked participants to answer based on the level of agreement across the construct. So each construct had about 3 questions to assess participants' perception. So the figure on the right side shows us that, largely speaking, the users rated the different constructs high, because 5 in this context is they agree and it's positive. The one thing I want to highlight here, or one of the 2 things I want to highlight here is the SR, which is the safety risk or perceived safety risk. Now, this particular construct was more of an inverse, which means that the higher the number, the more negative the perception, which is if they rated it at a 5, then that means they feel that there's a lot of risk associated with using the exoskeleton. And if they rated it 1, then it means that they don't perceive any risk when using the exoskeleton. So we can see here that the perceived safety risk was about 2.4, which shows that the folks who use it had some concerns with regards the safety risks that might be associated with using the exoskeleton. But regardless, the very last construct here, which is assessing the intention to recommend, showed that the folks who use the device were strongly in favor of recommending it to their peers. So again, that's positive overall. But again, we need to try this out, test the same construct on a larger population across the construction industry. So in summary, looking at some of the key findings, we were able to identify several exoskeletons that could be used in the construction industry to help us deal with work-related musculoskeletal concerns. We also saw that the error rates that we measured basically increased with temperature, but on the other hand, when we use exoskeletons, it could also reduce it, which shows that exos could help with productivity. We also found out that the muscle activations reduced not significantly, but it reduced when we had exoskeleton in the hot condition. We didn't see a big reduction in the room temperature, but we saw a bigger reduction in the hot conditions. For the exos, looking at their perceived exertion, exos increase the perceived exertion, so that calls for deeper exploration. Then we also asked participants about their perception towards using the technology, And we found out that largely speaking, across the contracts, the end users were more pro using the technology. With regards to possible, paths going forward, we propose that it's going to be important to look at not just the ability to reduce activation, but since we saw that the data showed perception of excitation was higher for the exo conditions, we have to think about this from a multi-criteria perspective. So not just saying, hey, it will help with fatigue. You need to consider other factors as well when you're deciding to use these technologies in construction. You need to have bigger sample sizes, focus on construction workers, and we also need to extend it into more construction-specific tasks and see how the exos will perform in that condition. All right, so I had to run through a little bit fast because I'm looking at the time, but I'm going to be open for questions. Here are the references that I use in this presentation.
We've got 1 minute here for questions here, so if you can wrap it up, we'll want to be able to engage with you.
Yeah, so I'm done. So just I say thanks to the folks who are supporting the research, and I'm open for questions. Thank you.
Which of the exos they were using during the task? And second, if there was a period of adaptation that they were before doing the task?
Yes, great question. So the first answer is we use an exo vest, which is provided by Bionics. Let me. So it's the Exo Bionics Exo vest. That's what we use for this study. And on the first day of the experiment, which was collecting baseline data, we actually asked them to put on the Exo vest and perform the activity for about 30, 40 minutes and ask them questions at the beginning about their ability to use the technology. And at the end of that particular process of adaptation, and we did not allow them stop until they had a 5/5 on the scale of them being okay with using the technology.
Okay, so it was run during multiple days. How many days it was?
So in total, we had 5 days. So the first day was to collect the baseline. Then the next 4 was for the 4 different conditions. And the days, and we spread the experiment, I think, every 72 hours to help them recover as well.
Sorry, I think my last question is 92 with a 50% index is a heat index of like 107 roughly, which is a dangerous heat index to be doing the condition. So how realistic will be to find this in a construction site?
So in the summer months, the temperature goes up significantly. At least in Alabama here, we easily record 106, 108 heat index. So our thresholds that we used for this study for the heat was for it to be high, but not very, very high. And if you, like you mentioned, the heat index was roughly like 99 to 101. And I think that is representative of what we typically see on hot days, which is what we're trying to target. We want to see how the technology would work in typical hot days during the summer months in areas where you have high temperatures.
Great. Thank you so very much. Appreciate your contribution.
Thank you.
It's a very timely contribution. We've been talking about technology, the introduction of AI and technology into various workplaces, and you came right after these discussions. So we appreciate your talk. Thank you.
Thanks for having me.
Next up is Katie Stearns. She's from the University of Georgia. Welcome, Bulldog. And Katie has interests in people that live in very rural areas that use biomass cook stoves. And we're talking about not really in Florida or Alabama. I think we have to be going to Rwanda and to Guatemala and to Peru. And where the use of biomass cook stoves is very common in indoors, and it changes the environment that you live in. And I'm so glad that we're going to hear about ways to address that.
All right, thank you. Thank you so much for the introduction, Dr. Kane. It's really great to be here in person with all of you for a change. I've been giving Zoom talks like many of you for the past couple years, and this is probably one of my last few conferences, events like this, as a PhD candidate. I am hoping to defend my dissertation in the next few months. And as Dr. Kane mentioned, I am from the University of Georgia. Go Dogs. And yeah, like I mentioned, it's really great to be here, especially near the end of my PhD endeavors. And today I'll be presenting to you actually one of my dissertation chapters. So what I have for you today is maybe a little bit different than some of the topics and themes that we've been talking about for the last day and a half or so, but I think by the end of my talk, you will hopefully see the significance to public health and global health and see how it's intricately intertwined into some sort of occupational health and safety as well. So with that, let's go ahead and get started. So here's a brief presentation outline I have for you today. So I'm going to be talking about the parent study from which my pilot study originates. It is called the Household Air Pollution Intervention Network Trial, or the HAPPN trial. So it is a cook stove intervention project that takes place in 4 countries in the developing world. I'll be touching a little bit on my involvement in the HAPPN trial. So, I've been around for about 5 years in the PhD program at this point, and I think some of my involvement in this multi-country study has a lot of the essence of this pilot grant as well. So I want to share that with you. And then finally, I will be emphasizing this pilot project that I worked on in which we measured one specific pollutant, nitrogen dioxide, in a subset of those HAPPN homes in Guatemala, Rwanda, and Peru. So household air pollution is this global phenomenon that describes people that are cooking with open fires inside their homes. So the homes are often relatively small, poorly ventilated, and the people that are at greatest exposures tend to be women and children. They are the ones that are spending disproportionate amounts of time at the home, or in the home and over these fires. And so the occupation, you could say, of this woman is mother. She provides for her family. She's cooking on these stoves day in and day out. So we wish to characterize her exposures. So household air pollution was attributed to over 2 million deaths in 2019. It is also a major cause of pneumonia, which is a huge concern, especially in children under the age of 5. It has been associated with birth outcomes like restricted growth and low birth weight, as well as increased blood pressure, especially in some of our older women, as well as cancer of the lungs, of course, and other various types of cancers as well, and cardiovascular and respiratory effects. So the scope, the impact of household air pollution on the world is really significant. So about 3.8 billion people worldwide, that's about half of the global population, is exposed to this form of household air pollution. It is their livelihood. It is the type of fuel that they have the most access to. And so what are some of the constituents of household air pollution that we are concerned about in these settings? That's a difficult question to answer because smoke is very much heterogeneous. However, there are some very common denominators that we continue to study in these types of settings. The first of which is particulate matter, particulate pollution. So PM 2.5 is the one that gets probably the most attention in all kinds of air pollution studies, but especially in household air pollution. So this diagram here that you're seeing, the white beads are PM 2.5, and it's showing the relative size compared to that blue circle, for example, is 1 grain of sand. So PM 2.5 has a lot of health implications because it can lodge deeply into the sensitive lung tissue. We also have black carbon, which is a component of PM 2.5. It's the most light-absorbing component of PM 2.5, so it has implications for climate change, and it also is associated with hypertension or high blood pressure. Then we have carbon monoxide, which many of us, or all of us, I think, are familiar with. You can't taste it, see it, or smell it, and so it's very lethal even at low concentrations. And then last but not least, we have nitrogen dioxide. So NO2, which is going to be the focus of my pilot project in a few minutes, is a byproduct of fuel combustion, so that's all you need to know about it for now. I will go into a lot more detail about NO2 as we keep going. So then enter the HAPPN study. So again, that's the Household Air Pollution Intervention Network study. Again, this is the parent study from which my actually all of my dissertation projects originate from, but this pilot project in specific. And so this map is showing all of the global partners that we have in the HAPPEN study. You can see University of Georgia is just one of those partners. And then in the red there are the 4 HAPPEN study sites. So we have Guatemala in Central America, Peru in South America, Rwanda is our sub-Saharan Africa site, and then we have India as well. So these regions in particular are pretty heavily hit by household air pollution, and so that was a huge driver in selecting those as the study sites for the HAPPEN study. So I want to talk to you briefly about the study design of the HAPPEN study. This is going to be very important for my pilot project once again, so I think it's important to go through what the study design is like. So first, we started out with 3,200 pregnant women. This is the largest HAP study of its kind, a pretty robust sample size, so that is 800 pregnant women in each of the 4 study sites. So we enrolled them into the study. We conducted a baseline assessment to see what their exposures to household air pollution were before we did anything else, before we intervened in their lives at all. And then we randomized them. So this is a randomized controlled trial. So that means half of the participants went to the control group, which is the continued use of their biomass stoves. The other half went to the intervention group, which is where they received a gas stove intervention and enough gas for the duration of the trial. So the total duration of the trial was about 18 months in total. So up through her entire pregnancy almost, and until the child turned about a year old. And so that leaves us with 3,200 index children. And so as the children grow up a little bit, which is where we are now in the HAPPEN trial, we are starting to measure their exposures as well. So the overarching question to the HAPPEN study is, will we see an exposure contrast, preferably an exposure reduction, as we go from the control homes to the intervention homes in terms of household air pollution exposures? So my involvement in the HAPPEN trial, like I said, I've been around for about almost 5 years at this point. And so I started off in the laboratory at the University of Georgia. We have a gravimetric laboratory. And the work that we do there is we process air filters that go inside of these air sampling monitors. So think about the air filters that go in your homes or your apartments. They capture dust, allergens, pet dander, all of those things that you don't want to breathe in. Well, these air samplers carry filters as well, for which PM2.5 and black carbon deposit onto. So at the University of Georgia, we weigh the filters, so gravimetric analysis, before sampling, and then after sampling, and then with some quick calculations, we can determine the PM2.5 that was deposited on those filters, as well as black carbon. So over the past 4 to 5 years, my team and I have processed upwards of 20,000 filters, so that has been a pretty huge accomplishment, I have to say, and we've been very busy over the past few years. So then at the end of 2019, I was given the opportunity by my PI and by HAPPEN leadership to send me off to Guatemala for about 5 months and to get my boots on the ground, my boots dirty. And I think that is what captures the very essence of this pilot grant. So that is why I wanted to mention my field research assignment that I completed in Guatemala at the end of 2019 and into early 2020. Oops. There we are. Okay, so I went from the lab into the field, and so I got to interact with the field technicians like Alejandro there, and the field nurses like Yamilet there in the middle, and we still talk in Spanish. I was completely immersed in the Spanish language as well, which was just an amazing side effect to my time down in Guatemala, so I got to really advance my fluency, which has been really important to me as well. And then just working alongside all of the field teams, observing, helping, listening to the questionnaires being administered in Spanish, meeting the participants, feeling the smoke in my eyes and in my throat as well. So my time in Guatemala came to an end on February 29th, 2020. It was a leap year, and then we know what happened just a couple short weeks later, really. A couple short weeks after being in the States, everything really changed. So all that to say, had there not been this COVID pandemic, I would have been able to go back to Guatemala and carry out this pilot project that I'm about to describe to you myself, but unfortunately, just due to all of the circumstances, I entrusted my friends in Guatemala and my colleagues in 2 other countries as well to carry out this pilot project, at least the field work on my behalf. So nitrogen dioxide, like I mentioned, is a product of fuel combustion. It doesn't really matter if the fuel is biomass fuel or if it's from your vehicle, from natural gas. So it is not heavily studied in these HAP settings, however, so that has been a knowledge gap that we wanted to characterize, especially in these women that are working day by day to provide for their families. So that is a knowledge gap. It does cause respiratory, all kinds of disorders and effects. Primarily asthma, that is not a primary outcome of the HAPPEN study actually, but it is an important consideration for sure. And so as HAPPEN investigators, we thought we would be almost remiss not to try and characterize exposures to this other pollutant that is not under the parent study. Okay, so this is a basic study design of the NO2 study. So our goal was to recruit 100 HAPPEN households in whichever of the 4 HAPPEN study sites chose to participate in this extra study. It was extra work for everyone, so it was completely optional. And so that was 50 control households and 50 intervention households. In each home, we took 2 samples, so 1 in the kitchen and 1 personal sample. So our target was 200 samples. Like I mentioned, we were able to include 3 study sites from the HAPPEN study site, and the sample sizes that we were able to achieve all basically vary due to COVID in some way. So if you guys have any questions about how it ended up that way, I can answer them afterwards. The instrumentation that we used was the Ogawa passive sampler. So I think most of us, all of us I think, are familiar with the concept of passive diffusion. So air containing nitrogen dioxide diffuses into this badge and interacts with a chemical coated on the filter inside. So we put this badge on the apron of the participant, and then we put one in her kitchen as well. So all of these measurements took place at regularly scheduled HAPPEN visits. That was really important for us to make sure we didn't add too much burden to the already really hardworking field teams. So in terms of the laboratory work, that was just pretty straightforward spectrophotometry that was done at Emory University by Dr. Barry Ryan. I am happy to say that I did finally make it into the lab with Dr. Ryan. There were some really strong uncertainties with COVID. We weren't able to socially distance for me to do the analyses myself, so he did carry out a lot of the lab analyses, but I did finally get to shadow him for a day, and experiences like that for us PhD students are really invaluable to get our hands on the samples and experience that part as well. Okay, so to quickly go through the results, which are preliminary, this is a bit hot off the press, which is why I was sending Emily and Kelly some very last-minute details. I was like, I just got the data unblinded, so I can actually show you what the data look like preliminarily. So in the dark blue there, you are seeing the personal exposures. And so on the far right, that is personal exposures in the control home, and then compared to personal exposures in the intervention home. And so what we are seeing is there was a significant decrease. It doesn't look like a huge decrease, but a significant decrease as we go from control participants to intervention participants. Again, this is in Guatemala. And then we see this similar trend in the kitchen measurements too, in that lighter color blue. So the red dashed line is the WHO annual guidelines for NO2, which is 20 parts per billion. So I'm going to spend just a minute talking about the Peru data, which is really interesting for a couple reasons. So first of all, we see non-significance. Another thing is we do see some levels even in the intervention homes that are slightly elevated over the WHO guidelines. One thing that I have not mentioned is that our Peru site is about 4,000 meters above sea level. And so NO2 is a gas, and so it is impacted by atmospheric pressure. At 4,000 meters above sea level, the atmospheric pressure is significantly decreased compared to at sea level. So one thing that I'm talking with my co-authors on is how we can adjust these data to reflect those rates of diffusion of NO2 that are impacted at high altitude. So one of the things that we're talking about is simply adjusting the WHO standard, because the WHO standard is calculated at sea level. And so basically with a little bit of number crunching, situating the numbers to reflect the lower altitude, the lower atmospheric pressure, as well as the lower temperature. It's very cold in Puno during the time that we sampled there. It caused about a 65% inflation in the WHO standard. So that's about 33 parts per billion. So this makes it a little bit easier to help us interpret the data with Peru, which has been a little bit more interesting. And then finally, for Rwanda, we had a much smaller sample size, again, due to factors by COVID, but we see a non-significant decrease between personal exposures, depending on which study arm the participants were in, and then a significant decrease in the intervention kitchens in terms of NO2 concentrations. So in conclusion, to wrap up, this study did contribute to research in terms of HAP studies and as well as NO2 studies, which haven't been completed as much in these HAP settings. So it kind of added to that lacking knowledge that we currently have. We also were able to compare exposures and concentrations between the two major fuel groups, so biomass and the liquefied petroleum gas stoves. And then this also helped us to evaluate the effectiveness of a cleaner cook stove intervention and to make sure that the cleaner cook stoves are in fact cleaner. With that, I want to thank all of you for listening to my talk. And please connect with me on LinkedIn if you wish. And thank you to the funding sources. This was largely supported by the NIOSH pilot training grant.
Questions for Katie Kearns?
Hi.
Hi.
That was so interesting. Thank you. And
Thank you.
clearly a lot of work. So good job. I realized that your study sites are kind of all over the map, right? Literally. And so I'm imagining that the biomass fuel type that these women use is different based on the location, which would then change the chemistry of the pollutant they're breathing in. So
Yes.
I was wondering if you have that information, if it played a role in your study, and then if not, if you could go back and like separate it out, and maybe you'd even see more significant changes that way.
That's a great question. I actually had that in a discussion slide, but then realized that I needed to cut down a little bit on my talk. So yes, the fuel sources do vary depending on the study site. So usually in Guatemala, what we're seeing, and Rwanda for that matter, is wood. And then in Peru, another uniqueness that adds to the Peru data set is they usually use cow dung. It is very readily available, and that, of course, is going to change the chemistry to some extent. Overall, I don't think it's going to change the trend of the data that we saw, but it is, I think, an important covariate that I'll need to explore in terms of modeling the data later. Yes, we actually, thank you for your question. Another one of my dissertation projects is actually parsing apart the chemical compositions of PM2.5 because, like I said, even with wood smoke, but PM2.5 specifically, there are a number of different sources. And so we're running some other data sets to look at the chemical composition using X-ray fluorescence. Thank you for your question.
Any other questions? Were any of the room dimensional or physical environmental parameters considered to normalize the exposure concentrations that you measured?
They were. That was a good question, too. Yes, we have the dimensions. That's all in the questionnaire data to determine the volume of air that is in the rooms, in the kitchens.
These types of cook stoves are very common in many different countries around the world, and they represent a really remarkable type of household air pollution that really affects a lot of people, particularly kids. So this is a really great project, and I'm really glad that that got thrown in here. And I really love the idea that we have an occupation for mothers, and the household is a workplace, and that's a consideration. I'm glad you brought that to the table. So from the University of Kentucky, I'm pleased to introduce Michaela Keener and Kimberly Tumlin. And we're going to be looking at some fatigue evaluation tools, this time applied to a completely different workforce, people that ride really fast horses. So this is looking at jockey positional stability and workday habits and tools to evaluate stability.
Thank you. I'm Kimberly Tumlin, and I am a professor or assistant professor in epidemiology and also the director of the Equestrian Athlete Initiative. So I'm going to introduce a little bit about what we're doing and how this project is fitting into our overall mission to look at total worker health of this unique population. The Equestrian Athlete Initiative has the mission to optimize health, wellness, and performance of the equestrian athlete. We're defining equestrian as anybody that's interacting with horses, whether they're riding or not. So this would also fall under those occupations that are farming or agriculturally based, as well as those that are sport based. And that is something that Wayne and I have had many talks about. Our jockeys fall into a sports occupation, but a lot of other people that interact with horses are actually in traditional agricultural occupations. And then we have a large population of avocational interactions with horses. So people that are choosing to participate with horses on their free time. So in our research, we actually have over 2,000 participants in 12 different projects. We launched this initiative in March of 2020. So we're pretty proud of having that many different participants in 2 years during the pandemic. And our goals for research are really to quantify the health-related quality of life in equestrians. So this includes capturing some longitudinal data on injury rates in particular, because there is a lot of undiagnosed injury and also unreported injury that occurs in both our vocational and avocational populations. So a big part of our initiative is that we engage the community, whatever community we're working with, and we work with that community directly. So let me give you a quick story about our American jockeys in particular. So I had the opportunity to previously go to a conference that's specific for just the jockey guild organization. And I did a little presentation on finding out what their wellness factors and safety ideas were about the industry. And I did an audience response presentation and asked them a simple question. I said, how is safety viewed in your occupation, in your job? And the number one answer that I got back was bullshit. And that hit home with me. And so when Michaela joined as the research coordinator of the Equestrian Athlete Initiative, we sat down and brainstormed. We had to do something. Now, we both have a background in the horse industry. We both ride, have ridden in different disciplines. Neither one of us have actually, you've ridden off the track thoroughbreds. I have not ridden race horses, okay? That's not my background. But we knew about the equestrian industry, and I knew how important it was to really engage the jockeys at their site of work, which had not been done previously. So with that in mind, we started to get ingrained into this community and realized that some of the information they were giving us were really these total worker health factors that were not being captured in literature that's out there. There is quite a bit of really good injury epidemiology literature on the jockey occupation in other countries. And in fact, there are some really great research groups that are coming out of Ireland and Australia that really focus on this occupation. But in American jockeys, there are some major gaps. So to give you a little bit of background about this job, they're elite athletes, but this is totally different than any other sports athlete in terms of how they earn their money and how their pay works in particular. So they're independent contractors. They usually have an agent that works for them that gets them rides. So they're not hired by the track, and each track functions as its own organizational business. So there is no national collective yet body that is providing oversight to tell each of these businesses how to actually run, and since they're independent contractors, they don't necessarily have to follow all of our traditional occupational health and safety rules. So their pay depends on that they ride and that they win. So these create some really interesting social dynamics that we need to consider when we're working with this population. So I wanted to go through to let you know kind of where the gaps in literature are right now. So this puzzle is kind of a roadmap to get us from the starting point of American jockeys. And again, I want to make sure that that's really clear. These are jockeys that are riding here in the States. We know, and NIOSH has actually recognized that the job of jockeying is extremely inherently dangerous. They're moving at speeds of up to about 35 miles per hour. They do wear protective equipment, but they have to purchase that equipment themselves. That is not provided. So they have to bring saddle, boots, and helmet. They all wear, I think they all wear, I won't say all, some of the smaller tracks, they may not wear a vest, but most of them wear a protective vest as well. Race meets in the United States are not seasonal. So like other sports where you have a season and then you have an off season and you can recover, not true in jockeying. It's year round, which means that you're traveling from track to track to track. So usually you're following up and down the East Coast, flying. You can be going from West to East Coast multiple times. And many of these jockeys are not only frequently traveling, but they don't have a home base. Many of them don't live in one area. They have either multiple hotel rooms or multiple apartments. They may have family in one spot, but they're constantly relocating their lifestyle as well. At this point now, as we move through this, many of these factors are not captured in literature. This is all from us talking to the jockeys and learning about them. They ride very long days. Exercising thoroughbreds in the morning starts usually around 5 a.m. Race meets usually start about between 11 and 12 to 1. Depends on the track. But they can also have multiple race meets where they're racing in the afternoon, and then they drive to another track in the evening to race in the evening in another state. So these jockeys may be working from 4 or 5 in the morning until 11 o'clock at night. Depends on the day. They have not only are the days long, they also then have to transport themselves. So they don't get a transport bus like a team would. They don't get the ability to have a private jet. Some of them might at the elite level, but the majority of them don't. They're working in every weather condition you can think of. So we talked about heat stress earlier today. Cold stress is a real issue here too. So unless the track is completely frozen solid, they are riding. So all of you that wake up and don't like snow, that's on the ground, if that track is not completely frozen, which most of them are not, they're out there riding. So they're getting cold exposures, heat exposures, rain, snow, lightning. All of these are a risk. One of the biggest things that maybe most people know about, we also have in the United States the lowest weights that are required for jockeying. So that's about 50 to 55 kilos, or about 112 pounds is average. And the other key, based on other, I know everyone's always like, what? Okay, and jockeys are not all short. So yes, I am about the stature of the average jockey, but there are several jockeys that are 5'7". 5'11's our tallest one that we've actually had. And so frames, it's not just about being a petite individual, it's about making the weight. You have to make weight every race. So unlike boxing, where you're making weight and you can go and take your calories and your hydration, jockeys have to maintain that weight every half hour, okay, throughout the race. So if they're racing back to back to back, they're maintaining that weight. Well, what that does is it contributes to these disordered eating habits. Long stretches of fasting, binging, taking in excessive alcohol, using other substances to make their weight. They also flip. Flipping is not as popular as it was several years ago, but it still occurs. Flipping is vomiting so that they make their weight. So even if they take in fluids, right before the race, they will eliminate. So obviously they're dehydrated, although not documented in literature in the American jockeys. Failure to report injury is huge here. If they don't race and they don't ride, or there's stigma attached to being injured, they're not going to report unless there's trust that's built. Remember that the tracks are functioning as individual organizations They're independent contractors coming to the tracks, so they don't have the protection if they say, oh, I've had 5 concussions, I'm not feeling so good today. If they don't ride, they don't get paid. On top of that, many of our jockeys are supporting families here in the States, and many of them are supporting families overseas as well. So they're sending money back to those families. Now that family support is also extremely important in their social support system. So one of the things that we've learned in integrating with this community is understanding how important the social support is. So this is where we're going with the quality of life. And in this particular project, Michaela is going to talk about how we were addressing trying to set the standard for what's going on in a workday.
Thank you. So the purposes of this study were to characterize the American jockey workday habits and to evaluate their stability and position in a task-specific stability and position in a work task. So we were at Keeneland Racetrack up outside of Lexington, Kentucky for this, and we actually did it over 2 days, or 2 race meets. We were there multiple days, and we saw our jockeys before they rode any race for the day, and then right after or after they went and showered and got all the mud off them, depending the track conditions. When we saw them beforehand, we asked them questions about how much they had slept the night before, had they traveled in the last 48 hours, was this driving or flying, had they fallen, had an injury or a suspected concussion in the last 6 months. If we'd already seen them during the race meet, it was since we last saw them had they fallen, and some of them had. And then if they'd also exercised horses that morning. Both before and after, we asked them about how much they drank, if it was water or other substances such as coffee, and Red Bull was another big one, as well as what they ate, and then how they perceived their energy, thirst, and hunger. And at the end of the day, we also asked them if they'd been in the sauna at all and how long they had been. We also pulled data from Equibase, which is a public database of all the races, their starts, where they started, where they finished. Was it a clean start or did they stumble out of the gate? What was their allowance? When they weigh in for a race, if they're weighing in at 116 pounds, that includes their gear. So that's how we can say their weight is. We have some data that says it's on average between about 112 and 114 pounds that they weigh by themselves. For our occupation-specific stability and position test, this is a test we had to create in our lab to work with this group. And so we flip a Bosu ball upside down, we put an accelerometer on their low back and on the center of the ball, and we ask them to get on it and squat in their racing position and hold it for 2 minutes. That's all we instruct them to. We don't tell them how low to get or anything. We just ask them to take their race position. And we did 2D biomechanics from our sagittal or our side view, and then from the front view as well. So for processing, I used Dartfish and got the angles you can see here from the sagittal or the side. We had hip, trunk, knee, ankle, and then ball angles. And then from the front, we looked at the ball's tilt as well as the distance between their ankles and the distance between their knees, because a lot of them collapse in their knees when they're on a racehorse to kind of balance themselves. The other thing you see this jockey doing, which is why I specifically chose this jockey, is some jockeys actually ride with uneven stirrups, and you can see them take that position as soon as they get on the ball. So this is a brand new test. We weren't sure how it would work. So we broke our accelerometer files into a full 2 minutes to see, one, did we need to do 2-minute tests, or could we get away with one? And we broke them also into the last 60 seconds versus the first 60 seconds to see if we were seeing more instability in that second minute after they'd been holding it. We chose 2 minutes because the longest race in America, which many people know as the Derby, the Preakness, and the Belmont, they are, some of the longer races last about 2 minutes. So with our jockeys, this is just looking at the data we have from the spring 2021 race meet at Keeneland. We had 37 jockeys total. 74 came back to do we had a total of 74 pre and post. There was 2 that did not come back for their post test because they either forgot. This is a very interesting population to work with at times. This is a male-dominant sport. About 95% are males, and our data showed that with only 2 female jockeys participating in the spring meet. And our average age was 35, but it ranged from 22 up to 55. And then there's a large Hispanic population of jockeys, so we have 46% of our jockeys in this sample were Hispanic. So what did we find? Well, on average, they were getting more sleep than we expected. A lot of them do take naps because if you can't eat, what are you going to do? You end up sleeping a lot, is basically what we found out. On average during their workday, and this did not matter what age they were, 22 to 55, on average they ate 263 calories by the end of their workday, which for Keeneland is about 6 p.m., and that's all they had. In total for consumption of fluids, that's water and other things, Red Bull, coffee, Monster, maybe a sip of Gatorade, very common answer, is 27 fluid ounces. Of my jockeys who did eat between their pre and post tests, 79% of them ate candy. 84% of them only ate candy. 54% were riding in the morning, and then on average, they were spending 33 minutes in the sauna each day. And about 70% get in the sauna during the day. And that kind of depends on what weights they have to weigh in on, but most of them do it even for 5 minutes to just warm up sometimes. From that data that we pulled from Equibase, we saw that we had 1 to 9 races a day, but on average, our jockeys were riding 3 races. And our younger jockeys were going farther distance or days, so 15 days, so just over 2 weeks between winning a race. That does not include the day that we were collecting data. We did have a lot that won on the day of data collection. Our older jockeys, so our 31 and above groups, we had 3 groups total, had an average of 8 days between wins. And their range of miles raced per day was 0.55 miles to 7.8 miles, but the average was 2.2. So when we look at our perceptions, at the beginning of the day, regardless of age, all of the jockeys felt like they were on top of the world. But at the end of the day, we saw that our jockeys who are 41 and older actually had this significant decrease in their energy perception. Then when we looked at their thirst, all of them decreased significantly from pre to post. And then again, we see this huge difference between our older jockeys and our younger jockeys, even though they're eating the same amount of calories on average. So regardless of how long they've been doing it, as soon as they get over 41 years of age, we see this sudden decrease. All of a sudden, they're feeling extremely hungry at the end of their day. Looking at their position, we saw that jockeys 18 to 30 did not change their position at all. Our jockeys 31 to 40, they actually decreased where their trunk was slightly and did not flex their knee as much. And then our oldest jockeys surprisingly actually came closer to the parallel with their trunk, and this caused them to put more weight in their heels and flex their knees less. We used root mean square values from our accelerometer data, and we did not see any significant difference. There was actually a slight increase in their stability at the end of the workday for our youngest group of jockeys. But we saw significant decreases specifically in the X direction, which is right to left, medial-lateral direction. And then this was not significant, but trending. If we had a slightly bigger sample size for each of the days, we might have seen it be significant, that as the race meet went on for Keeneland, they actually got more unstable, and they worsened over the race meet. And that's shown by the actual increase in the root mean square values. So in conclusion, the stability worsened significantly across the workday in jockeys who are 31 and older, specifically in that right to left direction. Our jockeys who are 31 to 40 flex their knees less, drop their trunk slightly, where we see that even more in the jockeys who are 41 years and older. We think that a lot of the stability worsening could be a result of those lifestyle factors, and we hope to continue to do similar stuff over a whole meet with a larger sample size and then across multiple meets. So thank you for UK Carrick for funding this, Keeneland and our jockeys. Like I said, very interesting group. I've never had to tell a participant to please go put on pants because they showed up in a bathrobe before. Stuart Brown, Billy Fryer, who is on the picture on the far side, right when you're looking at it, he was what we call our cat herder or a jockey herder to get them in, especially for pre-post testing. And then our lab, which is the Sports Medicine Research Institute, and our undergrads who did a lot of stuff.
Just had one quick question in terms of the demographics as you were going through with the different jockeys. Excellent presentation, by the way. I was curious if you asked questions about nicotine intake or tobacco usage as well to try to curb those eating habits, since a lot of sports people that I'm familiar with at my age group, they typically, if they're trying to make weight, they'll increase their nicotine intake to try to avoid those kind of the cravings, I should say.
That used to be a very common thing that we saw. You could smell the smoke on a lot of the jockeys, I heard way back. We did not ask them about tobacco intake, but there is only one jockey who you smell the smoke on. Everyone else is, especially the younger group, we saw them being more specific in the amounts they ate or drank. Oh, I ate 50 grams of this, and I had 8 ounces of this. Very specific. So we don't know if we think there's a generational thing.
Yeah, and just one other thing to add to that generational gap. Typically, the older generations, at least from what I've seen, more tobacco usage like cigarettes, versus my generation is more like e-cigarettes and nicotine delivery devices of the sort. So I'd be interested to see further if that's maybe the difference between why you're not seeing it with the younger generation, because they're using maybe just a different delivery method.
Yeah, that's a great point.
Thank you.
I've got 2 questions. One is, I didn't know anything about jockeys until you guys started collaborating with us. Has there been much literature on long-term health outcomes? Because this does not look like a very healthy lifestyle to me.
There is, to my knowledge, one paper out of Ireland looking at retired
One paper
Irish jockeys.
on long-term chronic health effects. And
And they were
so-
looking at if resting basal metabolic rate had decreased because such long-term low chronic energy intake, they assumed that they're.
Sounds like an area of research that's ripe for study. My second question is, whenever I place bets, I always look at the horse statistics, and I look at the jockey statistics too. And you can tell I'm not very good at picking the horses because I'm still working at an advanced age. But how much difference does the jockey make in whether a horse wins the race or not?
It can make a big difference. You definitely see that the better jockeys tend to get the better horses. You can look up what jockey is in the top standings at that track for that race meet. But that's why they actually have there's a weight allowance. They ride at bug weight if they're an apprentice jockey. So they actually ride as low as 110 pounds.
Excellent presentation. So just to continue that, it's a very different sport than any others. So the star is basically the horse. The jockey is somehow, he has to be really very good to be, and very famous to become a star. So I think that there is some, maybe, stigma associated with that because, as much as you work, you are not still the number one, it's the horse. And I think that psychologically it's a certain burden on them because of that. Did you in any way notice that, or have you documented that in any way?
Not that specifically. We do have a survey that we did this past fall with our jockeys that had a few questions about how they feel about their life in general. Are they happy? Are they content?
Yeah, so this fall meet that just passed, we actually had a concussion and quality. We used the Human Flourishing Survey questions out of Harvard, and then asked them to start to self-report concussions. And that work was really interesting. In particular, because they were willing to actually talk more to us now and be very open about what was going on. In terms of the horse being the star, they are not the same. They are a very humble group. So it's not like
Right.
going into an NFL locker room where, they're,
You are talking about the horse, right?
yeah, that's the horse. We're not allowed in the male locker room. We can go into the female jocks room, which was really insightful for us to know. But my husband had actually visited, and they just took him straight upstairs and walked him around, and he told me about how they interacted. So back to that social support piece. So even though they are the star, but they're not the star, the horses, they have such a strong community that being able to provide support for continuation of that community, especially for those younger jockeys that are coming in and those younger jockeys coming from other countries that have been trained in other countries, to help them cope with this concept of, you are the pilot,
Right.
but it depends because like Mike Smith is the star. He was on our slide. I mean, so when you reach a certain status, you
Right,
do
right.
become that star. We just want to start reaching like all of the jockeys, not just the Mike Smiths, although he is helpful.
Thank you.
Last question. Are there any old jockeys? Like what happened, like what do they do when they retire? Is that a population that you can access for?
I mean, our oldest jockey was 55. If you looked at him, you might think he was 75, but obviously not all of them age super well with their life habits. But they do, a lot of them, you'll see exercise riders that are ex-jockeys. It kind of depends how long they go. We're seeing that jockeys stay jockeys longer than ever before, so.
And it depends on reasons for retirement. So if they are part of the permanently disabled jockeys group because of injury, others have been forced into retirement because essentially they listened to their physician that said, if you have one more concussion, you are going to lose your life. So in that case, the biggest, not necessarily health issue, but is financial wellness. So because they weren't expecting to retire at 30. And so they had not prepared for that. So in terms of tapping into them, I have one that I call anytime I have a survey, who is a traditional Hispanic Spanish speaker. So whenever we're doing anything in Spanish language, I ask him, do these questions make sense from your profession? Because I am not, and you are not either. So yes, we do tap into them. And they're
Sounds like
amazing
a
people.
population that could stand to benefit from a longer life after they retire.
We agree.
We agree.
Thank you so very much. Our next speaker, and who'll close up our session for us this afternoon, is Dr. Libby McClure from our local institution here at UNH. And she will be talking about aluminum smelting, work exposures, and health right here locally in West Baden, North Carolina.
Thanks. Hey, everybody. Really honored to be here with such interesting and excellent presenters today. And it's an unfamiliar space to be in a room with a lot of people and up at a podium. So exciting. As was mentioned, I'm a postdoc at UNC Chapel Hill. And I did my dissertation research supported by the NIOSH pilot project grant. So I'll be talking about some of the work that was supported by that project grant. But I want to start with doing a land acknowledgement. We're located on the ancestral, traditional, and contemporary lands of the Eno, Saponi, Occaneechi, and Shakori peoples. And I also want to acknowledge that land acknowledgements don't absolve settler colonial structures of violence that have impacted Turtle Island, and that land acknowledges must include commitments to Native American and indigenous communities. As such, I acknowledge and support the sovereignty of North Carolina's federally recognized nation, the Eastern Band of the Cherokee, the state-recognized nations, the Coharie, Haliwa Saponi, Lumbee, Meherrin, Occaneechi Band of the Saponi, Saponi, and Wakimashoan, and the other Native American and indigenous people who call North Carolina their home, and those who were forcibly removed from the land. Moreover, I affirm that institutions of higher education, including but not limited to UNC, should work harder to recruit, retain, and support Indigenous students, staff, and faculty. And I hereby hold these institutions, as well as the profession of occupational epidemiology, accountable to the needs of Indigenous people. So the title of my talk is Aluminum Smelting Work Exposures and Health in West Baden, North Carolina. I'm going to talk about some background and motivation for the study, as well as 2 quantitative aims, and then a sort of more qualitative survey aim that we conducted. So starting with the background, the site of my research is Baden, North Carolina, which is in Stanley County, not too far from Charlotte, for those of you who aren't familiar. And a dam was built on the Yadkin River to power an aluminum smelting plant in 1913 there. The plant was operated by Alcoa for most of the 20th century until they shut down the operations in 2007. The town of Baden is what's called a company town, so that means that it was established by Alcoa, and Alcoa owned the housing, the facilities, the hospitals, the police, the schools, everything sort of public goods. And it was strictly racially segregated for residences and jobs, with Highway 740 being a barrier, and West Baden being mostly black, and East Baden being mostly white. The Alcoa facility, as well as its major dumping and contamination sites, are in West Baden. And I want to note now that I'll be using the terms white and black throughout the presentation to categorize individuals. These are not intended to represent biological or genetic differences, but the sociopolitical realities and histories that accompany a variety of racial identities in Baden. So this was collaborative and community-engaged research. I got connected to the Concerned Citizens of West Baden through an environmental justice class co-taught by a faculty member at UNC Chapel Hill, and Naima Mohammed, who is a co-director of the North Carolina Environmental Justice Network. The research questions for my dissertation were initiated by concerns from the Concerned Citizens of West Baden. And another of my collaborators, Pavitra Vasudevan, was a PhD student in geography at UNC at the time. And for her dissertation, she conducted a qualitative analysis and wrote a play that was first performed in Baden. So the photo sort of in the upper left is a follow-up conversation after the play was performed in Baden. And I'm going to read a quote from one of the former workers at the facility that motivated some of our aims. This particular worker is a member of the Concerned Citizens of West Baden, and he worked at the plant for 33 years. He said, "I'm one of the ones Alcoa told one time they would spend $1 million to keep from giving me a dime. Somebody now will hopefully understand that Alcoa wasn't who we thought they were, that we went through a lot of heartache, a lot of suffering, a lot of segregation to even be a part of Alcoa. We didn't discuss it with nobody. I've lived with the shame because I didn't speak out sooner. The old folks would say, 'Don't go running off at the mouth, you'll get the plant closed,' and they depended on it. I didn't want to trouble any of my family with my illness, but what if they've been affected and I didn't say nothing? How will they even know?" So this worker and several other workers from Alcoa and those who lived in Baden were the impetus for this project, and they had a number of concerns and uncertainties about the extent to which workers and their families were impacted by toxic exposures from the aluminum facility. Just some historical context of aluminum production in the U.S. The U.S. was the world's largest aluminum producer for decades, and in fact, control of the aluminum industry has been credited for the U.S.'s continued military dominance from World War II onward. And in its peak, the U.S. manufactured 80% of the world's aluminum, and Alcoa was the U.S.'s largest producer, and Baden was one of Alcoa's largest smelters. The production of aluminum is a three-stage process from bauxite ore. It's mined and then refined and then finally smelted. And each of these processes requires vast energy inputs and produces toxic outputs. So in traditional epidemiology studies, as probably everyone in the room is aware, we tend to focus on one exposure and one outcome. But in the smelting process, alumina is dissolved in pots that are maintained at a temperature of over 1,700 degrees Fahrenheit. And aluminum smelting workers experience a varying degree of toxic exposures and hazards. And so I'm listing a common set of agents to which workers are exposed to in this table. The International Agency for Research on Cancer classifies aluminum smelting occupational exposures in general in the most dangerous group, Group 1, which indicates they find sufficient evidence that it causes cancer in humans. And a lot of the literature is based in Europe and Canada, and a lot of it is conducted by industry itself. But it does document some associations between aluminum smelting work and disease and mortality outcomes. But very little research has been done to formally examine occupational characteristics and exposures by gender and race in the aluminum industry. And I include a photo of a worker in a pot room, which is the department that is hottest and most dangerous for most of the smelting process. Through the process of literature review for my dissertation, we found a few limitations with regard to addressing the concerns of the community partners. It confirms some of what we know from former workers. For example, we know that the least desirable and most dangerous jobs were in the pot room. However, most of the research is industry run, and the company makes the study design, research question, analytical, and publishing decisions. And it again, did not assess determinants of race and gender disparities in exposures or health outcomes related to them. And in general, didn't reflect the worker experience described by the concerned citizens of West Baden. So we did two sort of more traditional epidemiology aims for this study, and the first was to describe differences in job assignment and work exposures by race and gender. And I'm going to read a quote that captures some of the dangers associated with discrimination and job segregation at the plant. This worker was employed at the plant for 27 years. She said, "Any inferior job at the plant was done by black workers. I was in the second set of females in 1976 in the pot room. It was liquid fire, and I mean it ran like water. The white men would drop their pants, loosen screws on my equipment. When we saw danger, we caused static, but the men would say, 'You shouldn't be here anyway.'" So this aim used company records from the past 20 years of operation. The workforce was about 87% male and 26% black. Working with the concerned citizens of West Baden, we developed a danger ranking score based on all of the job titles that were in and departments that were in our records. Then we looked over time at the proportion of workers in jobs considered to be low danger by race and gender group. Consistent with the literature, workers identified jobs in the pot room as the highest danger jobs. And we found that black males were the least likely to be hired into low danger job and remained less likely to be in safe jobs even after 20 years working at the plant. The second traditional EPI aim was to characterize mortality among Baden facility workers. And this is a quote from another former worker, and it captures some concerns about the excess mortality among workers at the plant that many expressed in conversations at concerned citizens meetings. "You told my story. I'm a product of some of the sickness that you're still talking about because I've got asbestos in my lungs. And I'm sure there's a whole lot of other guys in here who's got all sorts of complications. So we didn't escape it, we just lived through some of it. I remember when I got in the 25-year club, they told me that I had put my name on the cemetery, that I had joined the death group. I laughed about it and thought it was all funny, but as I lived, it was so true." And so the cohort for this aim comes from union seniority records, and this was what a bulk of my pilot project funds were used for data collection and abstraction and digitizing. So we scanned these seniority files over a few days at the local office in Baden. And there's a picture in the lower left of Pavitra and Nate DeBono at the Local 303 office in March 2018. We use standardized mortality ratios to compare the expected number of deaths to the observed number of deaths in the worker population to the expected number of deaths in the general North Carolina population. And in this analysis, we found support for excess cancer, bladder cancer, mesothelioma, and respiratory cancer mortality among unionized Baden workers. And then we use standardized rate ratios to make internal comparisons. So we looked at deaths due to specific causes among workers who ever worked in the pot room compared to workers who never worked in the pot room. And we found that relative to workers who never worked in the pot room workers had excess cancer, bladder cancer, mesothelioma, and respiratory cancer mortality. So these are this is my dissertation in one slide. And the key findings were that Black workers were most likely to be hired into undesirable jobs and least likely to transition out of them as they spent time in the plant. The second aim was that there has been excess cancer mortality among unionized hourly Baden workers relative to the general population, and especially among pot room workers relative to those workers who never spent time in the pot room. And the third finding was a critical evaluation of occupational epidemiology methods and how they can operate in collusion with racial capitalism. We show how Black workers systematically get undercompensated for respiratory illness due to race-based metrics used in spirometry metrics. We did this through a simulation using publicly available worker data, and I didn't go into detail on this today, but I'm happy to answer questions about it if anyone's curious. And then one question that my collaborators and I have repeatedly asked ourselves is, why even do a health study? Can a health study address the workers' concerns we're hearing? Could an epidemiology study support local organizing, or is it more likely to be exploited to undermine the realities of life in Baden? In our study, we were concerned about certain traps and pitfalls that reproduce race as the problem to be contained or managed. So we developed this flyer that we shared with the Concerned Citizens of West Baden members at meetings. And in it, we tried to clearly introduce the reasons to do and not to do a health study and how to participate in a community survey that we developed. While survey methods are certainly familiar to many of us here, I want to cite a few reasons why this is different from traditional occupational epi methods. The survey itself was initiated by Baden residents' concerns, like the uncertainties that were discussed in one of the quotes I read, instead of by the company. We came up with the questions in collaboration with the concerned citizens, and we decided to use open-ended questions to raise questions about what is or isn't known or being studied about a topic, instead of isolating the effect of one exposure on one outcome in the context of aluminum smelting. And then in terms of training, the concerned citizens members participated in the initial trainings with the folks who conducted the surveys. And in terms of supporting the organizing work of the concerned citizens of West Baden, there are a number of ways in which the survey has been helpful for that. We've generated a roster of folks who worked at the plant and who continue to live in Baden and then who have moved out of Baden as well. We've completed 25 surveys so far. COVID has certainly put a damper on that, but we're still collecting surveys in person and over the phone, depending on folks' comfort level. And nearly everyone we've talked to who have been Black former workers at the Baden facility and their families experienced toxic work exposures, overt racism at work, and cancer in their family. It's also been an opportunity to share stories and involve less vocal members of the community to participate in the conversation that has involved a lot of intimidation from plant representatives. So, and then, it's offered us an opportunity to share this set of methodologies and collaboration with communities facing similar struggles. So I just want to quickly acknowledge my collaborators from the Concerned Citizens of West Baden, as well as my committee members and my funding and data sources, with a special shout out for the NIOSH pilot training grant.
Sorry. That was really great and really important work, so thank you. And if you don't know Courtney Woods in the School of Public Health at UNC, you should. Okay, good. So I'm so sorry if I missed this. It's getting late in the day, but so inhalation is the primary route of exposure, right?
So definitely before they introduced PPE in the plant, inhalation was a big issue. The first thing that was introduced were like just regular 3M masks.
Yeah.
But there is also concerns about dermal exposures.
That's what I was going to ask.
Yeah.
Okay.
People have talked too about take-home exposures that, you know, they weren't given uniforms to put on at home or to put on at the facility, so they would work, bring that dust home, and then partners would wash their uniforms with their family's laundry. And
How many smelting operations like that you reckon are around the country right now? I know in Florida we have a lot of bauxite being mined. I'm not aware of any smelting that goes on there.
yeah, I think that Alcoa still operates like 17 smelters in the country still, and then much of that has been transitioned to Iceland because of their copious water supplies to power the facilities. And I guess, like, strangely less restrictive industrial development practices in Iceland. So
That's interesting. And I know that a lot of the byproducts from that, from those types of industries are very sensitive to changes in pH. Metals, for example, will change their composition and valence state based on pH, and their bioavailability changes radically. So when you talk about climate change, and if you were to, around these smelting areas, like go into Google Maps, right, get a satellite view, these are not small facilities. And when you mine these things, these are landscape scale operations. They're really large. We just don't visit them every day. It's like taking a high school group to the dump for the first time. They've never seen a dump or something of that scale. It's really very eye-opening. I just wanted to mention that I'm really glad to hear this story and to hear this really great research, but also to comment that your advocacy for workers in different structures, both racially in terms and with regard to industry and with regard to position within workforces, I think is part of your voice. And it's so good to hear that we think we all need to have a voice that way. And I think advocacy is one of those constructs that we're taught. Of course we're advocates. Look at what we do for a living. We do good science. That's even a better advocate. And we publish that in peer-reviewed journals. But the real advocacy is the voice, right? That voice that we heard. And I think that we can all have that. We're not trained to do it, but it's not just acceptable. It's an opportunity to take the actual data, interpret it, work with people, and ground truth that, feed it back, and do something with it. That comes from people. People do that. So thank you. Tom, you had a question or a comment?
More technical, so I wasn't going to step all over your very elegant conclusions. The type of smelting process, do you know by chance, did they give it a name, Soderberg?
it was a Soderberg plant.
Yeah, so that's a particularly problematic process for the coal tars. So more modern ones don't use that process. They work more remotely. So the heat isn't as bad and the dangers aren't as bad. So there are improvements in the process, even though they are humongous.
Yeah, thanks for bringing that up. It certainly was a consideration, and yeah, they did do a big update to the Baden facility in, I think, the 70s, but it was primarily a Soderberg plant.
Thank you so very much for your contribution. And thank you all so much for sharing your science and your data, and mostly your stories of that, which make it real and bring it to the table for us. We're going to conclude the afternoon session. We're going to be convening not. In fact, we're not convening. We're having a really lovely afternoon and evening on our own. Have a really great time. We're going to be convening tomorrow morning. What time, John? Is it, say it? 8 o'clock. Yep, I'll say it for you. Have a really great, safe time this evening. Thank you all again for your contributions. And for those that contributed to the brainstorming session, that was really awesome. Really appreciate that. Looking forward to sharing back. Have a great eve.